Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see how to draw the Norton's equivalent circuit for a given circuit diagram. As we know that Norton equivalent circuit is a current source is connected with parallel to a resistor. Resistor is connected in parallel to the current source. This is terminal A and this is terminal B. Now the current source value is IN and resistor value is RN. Now to draw the Norton equivalent circuit, we need to find out the two parameters, that is IN and RN. On the next step, we will find the value of IN. So to find the value of IN, we need to short circuit the terminals A and B. Then we need to find out the amount of current flowing through the terminals A and B. As step 1, we will find the value of IN. So we have short circuited the terminals A and B. Now we will apply the loop or the mesh analysis to find the value of current IN which is flowing through the terminals A and B. So for that we will mark the loop currents, that is this, let us say this is I1 and this is I2 and this is I3. These are the loop currents. From these loop currents we can directly say that I1 is equal to 2 amps. Here IN is equal to I3. The value of I3 is equal to IN. Let us write the loop equation by applying KVL to the second loop. So let us start from here. The 4 ohm, let us start from 4 ohm resistor. So we can write 4 into I2, and the current through 4 ohm resistor is having the influence of I1 as well as I2. So I2 minus I1, as the direction of current I1 is opposite to that of the I2, we have write I2 minus I1, then plus 8 I2. The amount of current flowing through the 8 ohm resistor is I2 and voltage drop across this 8 ohm resistor is 8 into I2. Here the 5 ohm resistor is there. The current flowing through the 5 ohm resistor is having the influence of I2 and I3, but both are in opposite in direction. So we can write plus 5 into I2 minus I3. Then the loop is coming to 8 ohm resistor. The amount of current flowing through the 8 ohm resistor is I2 and voltage drop across the 8 ohm resistor is 8 into I2, and finally meets the negative terminal of the 12 volt source. So we can write negative 12 is equal to 0. This is the loop equation on applying the KVL. Next we will simplify this equation. So on simplification we can see here 4I2 minus 4I1 plus 8I2 plus 5I2 minus 5I3 plus 8I2 minus 12 is equal to 0. Now in this equation we will apply I1 is equal to 2 amps and then we will start to simplify. So when we applying I1 is equal to 2, then this term will become minus 8. So the minus 8 and this is minus 12, so it will become minus 20. Now 4I2 plus 8I2 will be 12I2 plus 5I2 will be 17I2 plus 8I2 will be 25I2 is available, and the I3 term is only one available, that is minus 5I3 minus 20 is equal to 0. Now we can write 25I2 minus 5I3 is equal to 20. And next we write the loop equation for the third loop. The current is I3, so we can simply write 5 into the current influences, the influencing currents are I2 and I3, both are in opposite in direction. So we can write 5i3 minus I2 is equal to 0. Now in this 5i3 minus 5i2 is equal to 0, let us say this is equation number 1 and let us say this is equation number 2. Now we are interested in the value of I3. So for simplification, we will multiply the equation 2 with 5, then the equation will become minus 25i2 plus 25i3 is equal to 0, and the equation 1 we can write directly as it is. The equation is 25i2 minus 5i3 is equal to 20. So when we solving this, we can find the 20i3 is equal to 20 and I3 is equal to 1 amp. Now I3 is equal to 1 amp we have found. So we know that I3 is equal to IN. So the short circuit current or IN is equal to 1 ampere. On step 2 we will find the value of Rn. To find the value of Rn, we need to turn off the independent sources. Here the current source was present, we have open circuited. Here the voltage source was present, we have short circuited. Now when we looking the circuit from the open circuited terminals A and B, we can draw the equivalent circuit. So this is 5 ohm is available. Here the 8 ohm, 4 ohm and one more 8 ohm resistors are connected in series. So we can draw as it is. So 8 plus 4 12 plus 8 will be 20 ohm. So both these are connected in parallel. Let us say this is terminal A and B, and the equivalent value for this parallel combination is 20 is in parallel with 5 will become 100 divided by 25, which is equal to 4 ohm. The value of Rn is equal to 4 ohm. Now we have found the value of Rn. On the previous step we have found the value of In, that is In is equal to 1 amp. Now we have the two values to draw the equivalent circuit. In this, the In is equal to 1 amps and Rn is equal to 4 ohm. This is the Norton equivalent circuit for the given circuit diagram. If you have any doubts, please write it on the comment box. I will reply. If you like this video, kindly hit the like button below this video. If you have not subscribed my channel, kindly subscribe it. Thank you so much.